Welcome back to the Explainer. Today, we're getting super practical. We're going to crack open the NIST playbook and break down the different ways you can actually build a zero trust architecture.
All right, let's just get right to it. It's the big question every cybersecurity student runs into. Zero trust is a philosophy, right? A set of principles. But how do you turn that philosophy into a real system that actually works?
So here's how we're going to break it down. First, we'll set the stage. Then we'll walk through the 4 main deployment models straight from NIST. And we'll finish up with a nice little cheat sheet that puts it all together for you.
All right, let's get into it. First things first, before we can compare anything, we need to talk about the key players that make any zero trust setup work. Okay, before we dive into the models, you've got to know the cast of characters. Think of it like a 3-part system. You've got the policy engine, that's the brain. It makes the ultimate yes or no decision. Then there's the policy administrator. It's like the manager that takes the brain's decision and tells the gatekeeper what to do. And finally, you have the policy enforcement point. This is the bouncer, the gatekeeper itself. It's the one that actually opens or closes the door to the resource.
Okay, pay close attention to this one because it's super important. That last piece, the policy enforcement point, or PEP, that's the key to everything we're about to talk about. Because where you decide to place that gatekeeper, that single decision changes the entire game. It literally defines which model you're using. So with that in mind, let's jump into our first model. This is probably the most classic one, the agent and gateway approach. So check this out. In this model, that gatekeeper, the PEP, is actually split into 2 pieces. You've got an agent on the user's computer, think of it like a little bodyguard that's always with them, and then you have a gateway sitting right in front of the resource they want to access. That's the doorman. The bodyguard talks to the doorman, and together, they enforce the access policy. So what's the bottom line here? Well, this gives you amazing tight control. It's perfect for company-owned laptops and desktops, where you can actually install and manage that agent. But that's also its biggest weakness, right? It's a no-go for bring your own device situations or when a guest needs access. All right, next up is a really interesting twist on that first model. This one isn't about protecting one single thing, it's about protecting a whole chunk of your network all at once. Right, so instead of putting a doorman at every single office door, this is like having one super secure checkpoint at the main entrance to the entire floor. The user's agent is still there on their device, but it's talking to a gateway that's guarding a whole collection of resources, like an old-school data center. This is a lifesaver when you're dealing with legacy systems, the stuff you can't easily change or modernize. But here's the trade-off, and it's a big one. You lose that fine-grained control inside the enclave. Once a user is past that main gate, they might be able to see other doors they don't have a key for.
Okay, so what if you can't install an agent at all? Let's look at a model that gets rid of that requirement completely.
This one's super easy to picture. Just think about any secure web portal you've ever used. You go to one website, you log in, and you access everything from there. That portal is the policy enforcement point. You don't need to install anything special on your computer, you just use your web browser.
The huge advantage here? Flexibility. This is your go-to model for BYOD policies or when you're working with outside contractors. But you knew there was a but, right? The trade-off is visibility. Since there's no agent on the device, you have way less information about how secure that device actually is. Okay, for our last model, we're going to flip the script a little. Instead of focusing on the device or the network, this one zooms way in and focuses on protecting the application itself. I love this analogy. This is like putting your most important app inside its own little armored bubble. It doesn't matter if the computer it's running on is a bit sketchy, the dangerous neighborhood of the host OS, because the app is safe and sound inside its protected sandbox. So this gives you fantastic protection for the application, especially if you can't trust the device it's running on. The downside? Well, it creates a whole new job for your IT team. Now they have to build, secure, and manage all of these individual sandboxed apps, which can be a ton of work.
Whew, okay, we've gone through all 4 models, so now let's put it all together and look at them side by side.
And there you have it. This is the slide to screenshot, folks, your ultimate cheat sheet for exams or design meetings. It lays out all 4 models, telling you exactly where the enforcement happens, what it's best used for, and what the biggest catch is. This is the whole strategy in one place.
So, what's the big takeaway from all this? It's that there is no single best model. You don't just pick one and call it a day. In the real world, most companies use a hybrid approach, mixing and matching these models to solve specific problems for specific users and specific data. And that really leaves us with one final question for you. Now that you have this NIST framework, think about your own network, at school or at work. Which of these models do you see in action? Can you spot how the data you use every single day is being protected